Hi, hello, welcome back to my channel. It's GCSE here, and today I'm going to be doing a kind of tutorial on how to solve quadratic, I can't even spell, quadratic inequalities. Now I am currently quite sick, so this is going to be a task for me, but hopefully I'll be able to shed some light on the complications of solving inequalities where you've got shading below, shading above, awkward terms. Yeah, hopefully this will help so that you can get the best mark you can in AS Maths or GCSE Further Maths. Enjoy the video. Just to let you know, I am still sick, so if you hear any coughing, spluttering, that's just me dying here while I'm trying to make this video. Enjoy. Well, people try and rub out. Okay, so question 1. Our equation is x squared minus 4x minus 5 is less than 0. Now we have a couple of things we need to do. 1, we need to solve for x. 2, we need to sketch. And 3, we need to determine range. Range is the, x is less than 50 or x is greater than or equal to 2. That is what range is. So let's start this question. If I can rub this out, like me, complete mess. There we go. So question 1, solve. This is a nice simple one because it factorizes quite nicely. We have our two brackets with x, they're still less than 0, and we get 5 and 1, 1 in the other, x plus 1, x minus 5, x is equal to 5, and x is equal to minus 1. Technically that is whenever this is equal to 0, because if it is greater than 0 then there are different values it can take, but that's what we're going to work out. So whenever this equals 0, those are two x values. Cars are driving past very loudly. Anyway, then we sketch. Now, your sketch does not need to be perfect. I could obviously spend lots of time, drawing out my graph. Here's my x and here's my y. And then minus 1 is here, minus 1. Here's 5. It could all be perfectly lined up here, minus 5 here. Doing a nice curve. Obviously that is quite good if you can do that. However, it is perfectly acceptable just to do this. And then there's 5, there's minus 1. Perfectly acceptable just to do that because the diagram is just to help you get your final answer. But anyway, we'll use the nice one. I'm going to switch color of pen. So we are wanting to find out whenever the expression here, which we can call y, because that's what, for example, it's like y equals, this graph is literally y equals x squared minus 4x minus 5. And so y is less than 0. So we're just calling this y and then less than 0. So on our graph, that looks like this is the y value here, obviously. Y is here. And we're looking for whenever y is under 0. So y is 0 at the origin and less than 0 in here, in this region here. So we are looking for the part of our curve, like the part of the curve that is underneath the y-axis. So that is from here all the way across to here. And our curve is greater than y. We continue these lines up. Our curve is greater than y here. and here. So it is less than 0 between these 2 points. Between there and there, the curve goes underneath, and so that's how you know where to shade. You're shading under 0 and in this point here. Hopefully that makes sense. That's the shading part, which is the most complicated part of this. Then you put down your x. This is for your range. X is less than 5 and x is greater than -1. And there we have our answer to question 1. Now I'll go on to a slightly harder one. Well, it's kind of the same level of difficulty, to be honest. Question. Let's just clear. Oh, you moved there. Question 2. Question 2. That is the. Well, I have a book here with questions because I can't really be bothered to, I can't be bothered to make up my own. Question 2 is actually the same equation. Is it? Yeah, it is. X squared minus 4x minus 5. But this time, we're looking for whenever it is greater than 0. So we solve and we get x equals -1, x equals 5. And we draw our graph. I'm going to do it this way this time. That's just the quick way, -1, and here is 5. It doesn't have to be to scale, as you can tell. That distance there is not a fifth of that distance, but it doesn't matter. Now, we're looking for, this is y here, your y, and we're looking for whenever y is greater than 0. This is the y-axis here, that's x. Here's the y here, and we're looking for whenever it is greater than 0, which is this point here, so we're looking for all the values up here. Now, the curve, if we draw our lines again at -1 and 5, sorry, they should be straight, but we can see that our y value is greater in this bit of it, so from the line this way, and from the line this way. So we shade this bit of the curve here, and this bit of the curve here, so just the bits of the curve that are above the axis. Obviously, if you see this bit here, technically it's not equal there because they're not outside the curve, if you know what I mean. So we've got outside the curve there and then inside the curve there. That's just how it works. But yeah, so you shade outside, which means that x is greater than 5 and x is also less than -1. And those are your two that's your two things for x. You can also check this by putting these into the calculator. They should both equal 0. And then if x is greater than 5, you put 6 in, you should get, what should you get? You should get, that's a good question. I forgot how this bit works. If I was to put in 6, so 6 squared minus 4 times 6 minus 5. Oh yeah, it should be greater than 0. It is 7. And if I was to put in, say, 4, which is not inside the range, I should get -5, which is less than 0. So that's how that works. Put in the values. I'll put a wee check thing here. Check. Plug in a value inside range. And then that should be equal to greater than 0, if you know what I mean, in this example. In question 2, close bracket, and then plug in value outside range, and should be equal to less than 0, which in this example, which means you have done the question right. So now we move on to a slightly harder example. Let's clear the screen, or the board, or whatever you want to call this. It's, in case you're wondering what I'm using a static whiteboard. It's basically a sheet of paper that like sticks to random surfaces. So yeah, that's what I'm using for this, instead of writing and wasting paper. Save the everything. Yes, I agree. Anyway, next question. we are going to use a negative curve. So we all know what a negative curve looks like. This is question 3 here. Negative curve is a sad curve. Our equation is 3 minus 5x minus 2x squared, and this is less than 0. So we factorize, and what you can do to factorize is just convert this to 2x squared plus 5x minus 3, and then you flip the sign and you get 0 there, obviously, but that's not what we're doing. That is possible, that's the dividing through by minus 1. If you divide or multiply through by minus 1, you have to flip the sign here. But we're not going to do that, we're putting it equal to 0, so 2x squared plus 5x minus 3 equals 0. Solve that and you get 2x, and you get 1x in this one equals 0, and then 2x minus 1, x plus 3, x equals half, and x equals minus 3. Those are your two values. We then draw our amazing curve. Here we have half, and here we have minus 3. Now, this is the curve if we had multiplied through by minus 1, but that is incorrect in this example because we did not multiply this bit to minus 1. We just multiplied the equals 0 by minus 1, not the original equation. So our curve actually looks like this, but it's pretty much the same thing. It's just half, and it is minus 3. So using our red pen, we have y here. Y is less than 0. So here's y here, here's x, and then y is less than 0 here. If we draw our lines here and here, where in the curve is y less than 0? Y is less than 0 this way, this way here. Technically starting from here it's this way, and starting from here it's this way, because the curve is still continuing. For example, that will keep going down and go infinitely that way, if you know what I mean? As it extends higher and higher, it wouldn't have that curvature, but it would keep going. So it is in here and in here. So then we get our values. X is greater than a half, and x is less than minus 3. But what technically you can do in this example here is what I kind of did the first time. If we rub this out, we get our, if we multiply this through by minus 1, so I'm just going to get rid of all this. Multiply this by minus 1 and you get 2x squared plus 5x minus 3, and switch this around is greater than 0. You then get this curve. There's a half. There's minus 3. And we are looking for, obviously, whenever, instead of y is now less than 0, y is greater than 0. Draw. That was really bad, but if we draw these, we're now looking this way whenever y is greater than 0, because the curve continues like that. Well, continues up, and it will eventually get infinitely that way, and then this way here, same thing happens. So look, our answer is actually exactly the same. We have x is greater than a half, and x is less than minus 3. So if you want to multiply through by minus 1, you must remember to flip the sign. Let me do this in red. Must remember to flip the sign if you want to multiply through by minus 1. Means you flip the sign. That is always a good way to make your quadratic positive, and also slightly easier to factorize, because I do not like factorizing negative quadratics. So that is how you solve quadratic inequalities. However, the hard bit of quadratic inequalities is the shading. It's the hardest part. So what you can do, I don't recommend it, but what you can do is memorize the shading. I'm going to draw 4 axes here, representing just x and y axes. I'll draw a curve like this, a curve, so same curve. Then the negative curve there, this is going to be, this curve is called y equals x squared plus x minus 3. Y equals x squared plus x minus 3. And this one here is going to be y equals minus x squared plus 3. And then y equals minus x squared plus 3. That's just literally the minus x squared curve moved up, but that's not for today. So here we have our curves. If we're looking for y, which is the equation, if we're looking for whenever y is not an equal sign, sorry, whenever y is less than 0 on a positive curve, y is always less than 0 inside this bit here, and y is always greater than 0 outside this bit here. That comes from obviously when you draw your lines, and from here it's that way, and from here it's that way, and then in here it's in there and in there, or that bit of the curve there. There are loads of different ways of explaining it, but this is what I think is probably one of the easiest ways to explain it. Then we have whenever y is that's a really bad y is greater than 0 and y is less than 0. So on this one, y is greater than 0 inside here, and y is less than 0 outside here. Does that make sense? Hopefully that makes sense. You can memorize that. I don't recommend it. In other words, I don't think there'll ever be a situation in which you shade in here. You never shade in there at any time. You know what I mean? You never shade inside this open bit. And then you also never shade in this bit here. It's either inside or outside of those bits. Yeah, hopefully that makes sense. You never shade in these bits or outside those bits. So you can memorize this shading chart, which isn't too difficult to memorize. Just write it out a couple of times, but that's just where it comes from, and that can help you just get the shading right on quadratic inequalities. So let me rub this out. Move on. Thank you. Thank you so much for watching. If you made it this far, thank you. Make sure you give this video a... Let's see if I can do this. There's a hand. That's definitely a hand saying like. Okay? And then hit that subscribe button. These types of videos do take me quite a while to make. These do take quite a while to make. I have to prepare these. I have to write these. I have to make sure I know how to do it myself. Yeah, these take quite a while. But thank you for watching, and I'll see you all in the next video. Bye.